A survey of adults ages 18 to 29 found that 91% use the internet. You randomly select 160 adults ages 18 to 29 and ask them if they use the internet. A. Find the probability that exactly 147 people say they use the internet. B. Find the probability that at least 147 people say they use the internet. C. Find the probability that fewer than 147 people say they use the internet. D. Are any of the probabilities in parts A through C unusual? Explain. Use a normal approximation to the binomial distribution if possible. In order to be able to know if we can use a normal approximation, we need to verify that this is a binomial distribution. So how do I do that? Well, I look at this right here. It says 91% use the internet, which means that 9% will not use the internet. So that right there means that I either have a true or false situation, so I can use the binomial distribution. This is a binomial distribution. In addition to that, I'm randomly selecting 160 adults, so that's going to be n. So n will be equal to 160. We'll go ahead and write p, which is my success, that's 0.91. And then we'll write Q, which is going to be failure or not using the internet. And now in order to determine if I can use a normal approximation, I have to use the two following statements. We have to find P times N, and P times N must be greater than or equal to 5. In addition, we need to find Q times N, and Q times N must also be greater than or equal to 5. If both of these are greater than or equal to 5, I can use the normal approximation. And if I can use the normal approximation, that means that the mean, mu, will be equal to the same thing as what we've already found as P times N. And then we need to understand what the standard deviation is going to be. And the standard deviation is simply going to be equal to the square root of the product of P, Q, and N. So P times Q times N. And I need to find all four of these values to make sure that I can use the normal approximation. So let's go ahead and find P times N, which is going to be 0.91, and we multiply that times 160, and I can tell just by looking at it that it will be greater than or equal to 5. This is equal to 145.6, which is most definitely greater than or equal to 5. And then we're going to look at Q times N, and Q, remember, is 0.09, and we're going to multiply that. And we see that multiplying 0.09 times 160 is equal to 14.4, which is also greater than or equal to 5. So we can use the normal approximation. Now that we know that we can use the normal approximation, we will go ahead and find the mean and the standard deviation using the formula. So the mean, well, that's pretty easy because it's the same thing as what we just found right here, and that's going to be 145.6. So then we'll go ahead and we will find the standard deviation by multiplying 0.91 times 0.09 times 160, and we will take the square root of that particular product to get the standard deviation for this particular distribution. And we'll see that we get 3.62, which is rounded to 2 decimal places. Now what we would do is convert 147, because that's the value that we're looking at right here. We want to look at 147, and we're going to talk about exactly, at least, and fewer. So we're going to have equals 147 that use the internet. At least means that we're going to be looking at greater than or equal to 147 that also use the internet. And then fewer than 147 means that we have less than 147. Now, we would normally convert these to z-scores and then go to the normal distribution table, but in this case, we're going to go ahead and use StatCrunch. However, before we can use StatCrunch for part A, we need to go ahead and understand that if x is equal to 147, we're going to be looking at 146.5 less than or equal to x less than or equal to 147.5. This is where we establish an interval of 1 around the x value, and we do this because probability distributions are continuous and not discrete. So we need to establish this continuity correction. So we are going to go ahead and still use StatCrunch in order to determine what the value for p of x is equal to 147 will be. So you will need to open StatCrunch by left-clicking the button that's either in your homework or on the left-hand side of your window. Left-click Stat, highlight Calculators, and scroll down to Normal. Left-click Normal. Now remember, this is going to be a between because it's 146.5 less than or equal to x less than or equal to 147.5, so left-click Between. The mean, as we've established, is 145.6. The standard deviation, as we have established, is 3.62. And we are looking for values between 146.5 and 147.5. Left-click Compute, and we now have a value of 0.10198, which we will then round to 0.1020. Now let's continue on to the next part, which is going to be part B. And in part B, we want to find the probability that x is greater than or equal to 147. In other words, P of x greater than or equal to 147. Once again, because this is a probability distribution, we are going to use the continuity correction, and we are going to use the following. P of x is greater than or equal to 146.5. And we will type this into StatCrunch also. Now you don't have to do anything because your calculator is already there. But this is not going to be a between, this will be a standard, so left click Standard. You want to change this from a less than or equal to a greater than or equal to, and then you're going to type in 146.5. You will left click Compute, and you get 0.40182. So the probability is 0.4018. And I can either use StatCrunch or I can just use the complement rule for this next one, which will be x is less than 147, which means that P, it's the probability of x is less than 147, which means that I could simply say it's 1 minus 0.4018. And this will be equal to 0.598. And those are our probabilities. And then finally we want to answer the last question, part D, and say, are any of the probabilities in part A through C unusual? Remember that for a probability to be considered unusual, that particular probability, which will be some P, must be less than 0.05. And if we look at all three of the probabilities, none of them are less than 0.05, so no, none of the probabilities are considered unusual.